Hello, in this video I'm going to be answering a question as follows. Is Google Earth's ocean viewer a reliable source of data? And this is an important question because I've posted several videos showing these underwater structures that I found on Google Earth. And it turns out that just like every other application, it's not like a it's not a perfect source of data with no errors. And there are obviously errors in every software program. The question is, how significant are they, and are they relevant to the specific areas that I have actually shown in the videos? And I'm going to be providing some evidence suggesting that this Google Earth is actually a reliable source of data. There's a two-step process that we are actually having to go through to show that certain underwater anomalies that I've shown you are actually evidence of a lost civilization. First of all, that they actually exist as represented. Second of all, these structures that do exist are actually man-made and not natural. So first of all, I'm going to go over some underwater anomalies that have actually been discussed by peer-reviewed scientific papers, and to show that specifically verticality and vertical areas of very high vertical relief are accurately displayed. So the Florida Canyon is a canyon that's located in the Gulf of Mexico. And it's discussed in this scientific research paper that was published in 1990. First of all, I'll just show you kind of what it looks like on the app. So Florida Canyon is one of the many canyons that lie on the western edge of the continental shelf of the Gulf of Mexico. And if you look a little bit closer, you'll see that there's many different canyons, almost like there's like over 10 just in this part of the viewer. But the Florida Canyon right here, that's located with a pin, identified with a pin, is the most interesting because it has a very unique structure, which you'll see as I get closer. The Florida Canyon, unlike the other canyons, has this semicircular cliff that, as you can see, is not completely vertical, but it's very close to vertical. It's maybe around 70 to 80 degrees. And the question is Google Earth actually showing this feature as it actually exists? Or is it just exaggerating the verticality of it and giving us an inaccurate impression of what the feature actually looks like? Well, it turns out that that scientific paper that I briefly showed you in the PowerPoint actually describes this semicircular cliff in more detail. And it turns out here that the Florida Canyon, the lower canyon ends abruptly at a 3-kilometer in diameter semicircular headwall that rises 750 meters with a 60-degree or greater slope angle. Indeed, that's exactly what we have here. The lower canyon ends abruptly at this semicircular headwall, which has, let's see, it's around 2.5 miles. It's mentioned in the article. And it does actually, it does actually separate the lower canyon, for example, the lower canyon, which is this part, from the upper canyon, which is up here. It does separate those two portions of the canyon. And the cliff is not exaggerating the steepness and the verticality of this cliff. This is clearly a cliff that is greater than 60 degrees in slope. And so this is one example of a feature that is actually Google Earth's. And so, but of course, just one example is not good enough to make an argument. So let's go on to another example. The Mortos Trough is actually a feature that I mentioned in another video that I posted maybe around last week. And in this video, I mentioned how the Mortos Trough could possibly be a ditch that's referred to in Plato's dialogues, a ditch that's actually located in Atlantis. But that's really getting ahead of ourselves. I should not have really gone that far without really setting the groundwork to build a reliable argument for it. And the first step in building that argument is actually to show that the data is actually reliable. And so the Muertos Trough is this east-west trending trough that lies at the base of Puerto Rico and eastern Hispaniola. It's located at a depth of around 15 to around 17,000 feet. And as we will see, in Google Earth, it actually shows that the Muertos Trough I'm just going to the Mortos Trough right now. It actually shows that the Mortos Trough has like this really steep slope on the southern edge of it. For example, as you can see here, this area is the northern part of the trough. This is the southern edge of the trough, as you can see from the direction the compass is pointing. North is to the left and south is to the right. So here's to the right, and so this is the south part. And as you can see, there's like a very, very steep cliff that runs along the entire portion of the trough, entire southern edge of the trough. And ignore this thing for now. Just because there are some parts of the data shown in Google Earth that might be flawed doesn't mean that everything is flawed. That's the point I'm trying to get across. And we have this cliff that runs along the entire southern edge of the trough, and it's at a steepness of around 60 degrees. And it turns out here that this book, which is describing the new discoveries of a underwater surveying expedition named Gloria, this was published in 1996, and it's written by actual geologists. And so here we have at the south side, this is what the Muertos Trough is described as. This is cut off because these two, this part of the text was on a different page, so I had to kind of stitch it together here. The trough is bordered on its south side by north-facing scarps. And scarp specifically is a geological term for cliffs. And it explains that they are bending of the Caribbean plate beneath the Greater Antilles. And so the south face, the southern boundary of the trough, it is said in the article, is made up of north-facing scarps or cliffs. And that's exactly what we see here. So it's another example of Google Earth actually reliably showing verticality that is actually verified in a peer-reviewed scientific article. In other words, Google Earth is not just exaggerating these areas. They are actually being represented as they really exist in this software application, as remarkable as it sounds. And so what does that mean? That means that we have an example of at least two named geological features that we actually know are being accurately represented by Google Earth. So why should other features that are represented vertically, for example, why should this feature that's also a feature with a lot of verticality and a steep cliff simply be an error that's produced by Google Earth when we have seen clear examples of vertical formations that clearly are represented accurately? So my point is that Google Earth is actually a reliable instrument. It's giving us accurate data. And the only challenge that we really have is actually interpreting that data and understand what it's trying to say. And as I was saying before, just because this feature may be accurately represented by Google Earth, as I have argued that it is, doesn't mean that it's necessarily man-made. For example, this could very well be a natural formation. But the question is, what natural process would create it? And what natural process would create a cliff of this size and of this symmetry and this complexity? And the question is, there aren't that many geological processes that can do that. And so the argument is that these vertical features and these vertical formations that are lying underwater are likely man-made and hence are probably evidence of an ancient civilization.